we want to integrate this beast. The usual route is through trig substitution, ending up with the inverse tangent of x. But why go there when we can use partial fractions? We begin by factoring this sum of squares into a pair of complex conjugates. This leads to our partial fractions. What are a and b? A little algebra leads us to a pair of equations which we can solve by inspection. A equals b equals 1/2. This is the form that we need. Now we can integrate. First, pull out the 1/2. Separate the fractions into two integrals. We need derivatives of the denominators in the numerators, so we can easily integrate and combine the two solutions into one compact form. And we're done. But wait, how is this the inverse tangent of x? Here is the complex plane and a unit circle. We mark 1 plus ix and 1 minus ix as points on the plane. The polar forms of the complex numbers help us reduce the rational expression into something with an easy logarithm. We cancel out the 2I, and our result is simply theta. Yes, that messy complex logarithm is just an angle. This line has a length of x, but it's also the tangent of theta. So theta is the inverse tangent of x, the solution to our integral. Yes, plus c. And Bob's your uncle.